Good morning, folks. This is Jason Passini with IBM's Hybrid Cloud Sales Team, and welcome to this week's Integration and Development webcast. Our guest presenter this week is Kim Clark, who you may recall as integration architect and part of our offering management organization. And Kim had delivered a 5-part series in Q4 that was focused around Agile Integration Architectures. And as part of that series, we had topics including the importance of breaking up the ESB, decentralizing integration. We talked about the benefits of containerization, as well as the roles of API management and messaging within this Agile Integration Architecture. So what we had planned for today is really an update to that series. And as you can see here, we're actually on part 6, which is a bit of a deeper dive into granularity. And I think we've probably got somewhere between 20 and 25 minutes of content for you this morning. And as always, as we're going through the material, if you do have any questions, you can always submit them via the chat. And if there are things that we don't address during the course of the presentation, we can always circle back to them at the conclusion. And if anyone does want to get access to the recording of today's presentation, just drop me a note in the chat with your email, and I'll see that you get added to the box folder. And you'll have access not only to today's presentation, but all of the recordings that we've created over the past year or so. So with those opening comments out of the way, I'm going to just hand things over to Kim so we can get started, as I know we've got a lot of content to share with you this morning. So Kim, all yours, and we can take it away.
Thanks, Jason. Yeah, nice to be back. Welcome to 2019. We're a fair way into it now. And what I really wanted to cover today was sort of take the topics that we'd talked about around Agile Integration Architecture last year and start deep diving into some of the specific aspects. And today I thought what I'd do was pick off just one of them. We've only got 20 minutes, so it's probably best to just focus in on one area and look at the fine-grained deployment, that aspect of Agile Integration Architecture. Now, it's possible that some of you weren't present on some of those earlier calls. I'm going to give a very brief overview, but of course you can always go back and listen to the depth material as well. Talking about Agile Integration Architecture, I would typically have started with this picture, which is the one I was using up until 2018. Thankfully, we've finally got round to tidying up this picture so it's more in theme with the rest of the stuff. What the picture is depicting on the far left-hand side is a traditional centralized enterprise service bus kind of integration architecture. At the bottom are the systems of record and then systems of engagement towards the top. And the aim of Agile Integration Architecture is to enable us to be more nimble in the way that we create integrations. And so as we move into the second column, you can see that one of the key things that's happened is the breaking up of that enterprise service bus into smaller pieces. And there's a strong hint at the bottom that one of the ways to do that, and probably the most valuable way to do that, is using containerization technology in the same way as is being used in the microservices architecture for applications. And then the furthest right column, which is further than we'll focus on today, is then decentralizing the integration, saying, well, okay, we've broken it up into small pieces. Maybe we can farm it out into the individual application teams. Just to put some context here, most customers I speak to are moving from the first column to the second column and starting to look at putting their integrations in containers and getting the benefits from doing that. A small number of customers in pockets of the organization are doing what's in the far right-hand column and starting to really change the ownership of integration into the application teams. It's definitely not something that's happening broadly across all enterprises, and even within a given enterprise, it's only happening in some pockets of the organization. We're going to focus today on granularity, the granularity of the integrations themselves. Yes, we're going to break up an integration into many pieces, but how many pieces and which things would stay together is really the topic for today. And if we just look at this slightly more detailed picture, I also want to reinforce something else before we go into talking about the breaking up of the enterprise service bus integrations. You can see probably fairly clearly now from the first column to the second column, how important that API gateway has become, because it's now, that's the single entry point for all of our different integrations. It's now really fundamental to the structure of the way we go forward, where before it was almost optional as to whether you separated out the gateway. Now it's becoming an imperative. And just to reinforce that, a slightly larger diagrammatic representation of that. So, you know, the API gateway there is providing that upward-facing, outward-facing exposure. It's the control point for all the routing, the versioning, the traffic management of the requests that are coming in, all of the things that are consumer-facing, essentially. And on top of that, if it's more than just a gateway, if you're putting a full API management facility around it, such as API Connect, that would be our product there, then that also gives you the socialization aspects. So enabling consumers to discover the APIs, to find the documentation they need in order to use them, subscribe themselves to use it, and so on. So having that separated layer allows the integration to focus on what it's good at. So really that's the implementation of the underlying API. And mostly that's around things like composition, the integration logic, the aggregation of things perhaps from multiple different sources or multiple requests to the same source. And then underneath that, the deep connectivity needed to get through to perhaps quite old back-end systems with unusual protocols and data formats and so on. So that separation of concerns between gateway and integration is really fundamental before you can start to really break up the integration layer. And one more thing I want to cover before we really get into the granularity in depth, because this is directly pertinent to it, is from conversations I've been having in early 2019, it's clear that because we've talked so much about moving to containers, I think some customers, quite understandably, have assumed that maybe that's their only choice. Maybe that's the only thing they can do. Now, App Connect Enterprise, which is version 11 of what was before IBM Integration Bus, that was versions 9 and 10. And before that was WebSphere Message Broker, which was version 8. These are different versions of the same underlying runtime. We've just been progressively making it more and more suited to the possibility of running in a container. And one of the things that we did in order to do that was to enable you to run the integration servers on their own without necessarily needing the integration node that looks after the servers. Now, what are your options if you're upgrading from one of those older versions to App Connect Enterprise? Well, in fact, one of your options is stay as you are. And it's important to understand that, you know, we are supporting any customer that wants to continue using App Connect Enterprise the way they do today, at the same level of granularity as they do today, still in that topology that involves an integration node. That hasn't gone away. We recognize many customers will at least want to do that in the first instance, maybe before they move to other topologies, and some may want to stay on that for a while. It's also worth recognizing that you can do some of the granularity aspects, the fine-grained deployment, even using the topology as it stands. And many customers have done this. Many customers have made use of what used to be called execution groups, if we go back a fair way, integration servers, as a way of breaking up the bigger topology into smaller groups of flows. And so they would have perhaps, you know, in this case I've shown some 70 flows in one integration server, 30 different flows in another, so different integrations in each. And so, you know, and you could break it down more than that. You could have many more. But there would come a point as you started breaking it down more and more where you'd sort of think, well, actually, you know what? Where I'm headed is the same direction as where the container platforms are headed. That really fine-grained, full isolation that I would get from that. And so that's when you can look at the more cloud-native style of deployment. And you'll notice in this bottom one, there are no integration nodes. So we're deploying just the integration server. All of the things that the integration node used to do for us are being done by the container platform. So the container platform typically being Kubernetes, that's the one that we're focused on. So, you know, the fact that you are using Docker containers and Kubernetes takes away the need to have that integration node, because it changes the way you do deployment, and it changes the way you do replication and load balancing and availability and things like that. So there are options, and that's important for me to put across. Containers is one of the options. We would like people to go there. We think it offers some great benefits, but we're certainly not forcing you to go there. So let's have a look. On the left-hand side, we've got, let's just focus in on that integration bus that's got a number of integrations within it. And what's the first thing we would do to break up the integration bus into separate pieces? Well, the most logical first split is by domain and business domains, and many customers have already done this. You've only got to take an example of a large insurance company, and you would immediately see that they would have separated things out into probably a separate installation of an integration service for life and pensions integrations, and another separate one for healthcare related ones, and another set for maybe general car and house insurance and things. So they would have already broken by business domains and possibly even by subdomains within those businesses as well, because there are different concerns in each of those areas, and maybe they've even got separate funding for the different areas as well. So obviously that is the first split that's going to happen. But then what happens after that? How do we then go to split up within an individual domain? So we take that maybe the 100 integrations. It's not unusual to hear a customer saying that they've got hundreds of integrations on a pair of integration servers, and to take 100 integrations or more and turn that into 100 containers feels like making your life too complex. It feels like you've got too many moving parts. Do you really need to go to that level of granularity? Well, if you don't, then what would the grouping be? What would we choose for the grouping? And so I've got a few examples that I'm just going to talk through here, which should just give us some idea of where we might head in that territory. So the first example is probably the most obvious one. If I wanted to scale completely independently and dynamically, I want to make use of that cloud native capability of Kubernetes to spark up new containers for me just as and when they're needed. I can give it a policy that says that you can stretch this anything between 2 and 7 or 2 and 20 replicas depending on the usage coming in. And we might have an integration that's serving something that's very time critical. So, first thing when people wake up in the morning, the first thing they do is get on their phones. They start looking at various different applications that they use on a daily basis. They perhaps start clicking through to various advertisements. You can just imagine, there are certain peak times through the day when we expect to have higher load depending on what our business function is. And that might only last for half an hour. It may only last for minutes. If it's an advertising break that's in a particularly big show, then you might suddenly find a really high hit rate on a particular thing. So that kind of scalability is something that the cloud native platforms are really well suited to solve. But what we don't want to do is scale up every integration for that. We only want to scale up the integrations that are actually affected by it. So that's a nice obvious reason for that isolation and independent scaling. It's worth bearing in mind that many of the integrations that we've created over the years may actually be relatively stable now. They may not have been touched in 4 years. They may be just running quite happily. The load that we expect to go through them is a known load. Nothing's changing. Well, if nothing's changing, a lot of the benefits of breaking them out into separate containers have gone away, because we don't need them in a different life cycle. We don't need them to scale separately. We're not asking for different resilience requirements from them. Maybe they could live together in a single integration. And I think for many customers that are moving a large number of integrations across, there'll be a suite of those that are essentially stable and will probably make sense to sit together in a container. Taking the example of lifecycle, so what if things always change together? So I've got 4 different integrations, but they're all actually providing integrations to the same backend system that has the same data model. And the most common change I find in that particular set of integrations is when the backend system's data model changes. And when that happens, it changes all the integrations together. So I always end up deploying them together. I never deploy them independently. In fact, it's really convenient for me to have them together and be able to deploy them as a set. So in fact, having them together in one container would make a lot of sense for me. So things that have a similar life cycle because of something that's a clear dependency between them probably makes sense to draw them together. Speaking of dependencies, another common dependency is MQ, especially in IBM integration bus flows, Connect Enterprise flows. Not surprisingly, because it used to be really fundamental to the product, and in fact, from version 9 and prior, you couldn't not install it. You had to have MQ present. And so many flows are built with that in mind, especially the historical ones. Now, if they are using certain features, then they need to have not only connectivity to MQ, but it has to have a local MQ server. And I'm going to talk a lot more about this on the next slide. But if that's the case, you've got a number of integrations that need to have a local MQ server. And a common reason for that is if they're doing something that relates to a two-phase commit transaction, perhaps between MQ and the database, then they have to have that local version of the MQ server. Maybe it makes sense to have those in a container together as well. Another reason to draw things together might be the resilience requirement. So if I had a particularly high availability requirement, where I was looking at perhaps the need to have at least 3 or 5 replicas set up by Kubernetes, always present, to make sure that if I did have a failure in one of the replicas, it actually has very little effect in the consumers that are using it. So I could set it up with a minimum number of replications, clearly using more resources, but doing that for a reason, because I need that kind of availability. And I can do that on an isolated basis just for the functions, the integrations that I actually need to do that for. So again, making use of the isolation that I'm getting from containers, these are things that I can do in a container environment that I wouldn't necessarily be able to do if we were doing this just using, say, the equivalent of execution groups or integration servers in the older traditional topology. And then looking at cross dependencies between two integrations. So what if for one integration to work, it has to make a real-time request to another integration, and if that integration is not there, it's never going to work anyway. Would it make sense perhaps to deploy those two integrations together so that at least they know that if one's up, the other one is always up as well? Now, you could argue that we could do this perhaps more product-wise, in a more logical way, product-wise, by using something like a subflow. So there could be circumstances where we brought two integrations together by making them actually all part of the same flow, but just a separated subflow. But there's certainly going to be circumstances when we might want to have them as separate instances within the container. And so we could certainly do that as well. So that's given us 6 different examples. We could certainly come up with more, but I felt that was probably the most common reasons that people might find for grouping integrations together. I think, loosely speaking, having spoken to customers about the way that they group integrations into execution groups today, then getting down to a sort of a level of 5 to 10 integrations per grouping is quite common, and that sort of it has a sort of logic to it. That sometimes refers to the operations that are being performed on a resource, so the create, read, update, and delete, for example. So I think that kind of number is quite a likely place where people are going to end up. So let's just take a little delve into the container images that we would start from to build out core topologies. What do I mean by that? So we're providing images for App Connect Enterprise on Docker Hub that you can just go and use straight away. So they're sanctioned by us, they're made available by us. We provide the far left one here and the far right one. In fact, we don't have a separate image for the middle one at the moment. We may do. And so we provide one that just provides a raw integration server in the Docker image. And then we also provide one that provides a local queue manager, which is the one on the far right there. We've separated out here the possibility of having a Docker image that does or doesn't have the MQ client, just simply because there's some footprint to the MQ client, and you might want your Docker images to be as small as you possibly can. And so, having the option to choose a base image that either does or doesn't have an MQ client might be useful. As it turns out, that you could use either of those images to bear down onto the same topology. So what I'm showing below here, and RS stands for the replica set. So that's a Kubernetes term for the mechanism used to replicate a Docker image once it's been built into the Kubernetes environment as a container. So Kubernetes will take your Docker image. In fact, you would have also layered your bar file on top of your Docker image as well. So you'd have combined one of the upper Docker images with your bar file, created a further image, given that to Kubernetes, and then let it scale it. And in this case, on these two far left images, the scaling is completely elastic. So we can just simply say to Kubernetes, make more if you need to. And we can set the parameters around how many more and what the minimum number of replicas should be. And the reason we can do that is because these are completely stateless from a topology point of view. So there's no requirement here for any state stored to the disk that needs to be retained between one start of a container and another. And as we replicate out, again, there's no containment across them. So that's a nice, simple, elastic scaling architecture. And it's surprising just how often this would be more than enough for modern day integrations. So if we're exposing things over, say, a REST API and talking to things that are REST or web services underneath, or any of the other standard nodes that we've got within the product, then quite often this nicely elastically scaling architecture would work quite happily. And indeed, talking to MQ, just because MQ is stateful itself, doesn't actually affect the replication of ACE in this circumstance, because if we're connecting it over a client, then MQ is responsible for the state, and there's no state held in the integration server itself. So let's have a look at what happens on the other side here. So the Docker image that contains a local queue manager, inevitably what that's implying is that the local queue manager is going to be persisting some messages to local disk. Now, we could possibly take the approach of still having an elastically scaling topology. So on the far left there, what you're seeing is the elastic scaling with non-persistent local MQ. That's a long phrase. What does it mean? It's effectively saying we're not going to provide a shared persistent volume that would still be present even if a whole Kubernetes worker node failed and came back up again, even though there is a local MQ queue manager. Because what we might be doing in there might be, say, for example, using the aggregation nodes to do some parallel requests to back-end systems and retrieve answers back. And if it were to fall over in the middle of doing one of those requests, perhaps it's essentially a read-only request anyway. And so we don't actually care that we lost the responses because the caller is going to make another request anyway. And so we could use that far left-hand topology and still have our elastic scaling provided naturally by Kubernetes, and have a non-persistent local MQ. So the MQ is persisting to disk, but it's just persisting into the local disk of the container, and it would be lost in a crash. But then as we move towards the right, the middle of the three on the right is actually the equivalent of a typical traditional topology today. Now, a typical traditional topology today for IBM Integration Bus or Connect Enterprise is an HA pair, with one of those pairs probably dormant and the other one up and running, so an active passive on warm or cold standby. And Kubernetes can provide that for you in a subtly different way by saying, you've given me this nice lightweight image from integration server that I can restart really quickly. So I'll make your backup, the second of your HA pair available to you immediately, as soon as your main one fails. So if the first one fails, I will reinstate your container based off of the image and build it up really quickly, because that's what containers allow you to do. They're much, much more lightweight than starting up a virtual machine or something heavy like that. And we've been making radical changes to the integration server's runtime to enable it to start very quickly as well. So ultimately, you can get largely what you have today in your traditional topologies from that middle instance. It's statically scaled, but then so is your HA pair today. So the only thing you could do with your HA pair today to scale it would be to vertically scale it by adding more instances in. And moving to some of the more advanced topologies that some people may have is where we move to the furthest right example. So if we really did want to be able to scale out the underlying MQ, for example, to get higher throughput through, then we can do that. And you notice we're using stateful sets in Kubernetes here on the far right-hand side. That really essentially means that the individual instances have a known IP address and a sequential set of IP addresses, so that we know where they are. We can load balance across them using the usual techniques that we would have. Really what we're saying is that for circumstances where you have integrations that need a local MQ manager, and where that queue is being used in a way where you really do care about the local messages, that center of the three on the right-hand side may well be the topology that you need. But remember that we're breaking up our large enterprise service bus into lots of small factions, and we may find many of the integrations don't require that, and may well be easily satisfied by the elastic scaling topologies on the left-hand side. And so we can take advantage of just the topology we need and build that into the integration group. So each integration group would be effectively assigned one of these topologies, and these topologies are represented by Helm charts. So you'd have what's called a Helm chart in Kubernetes, which defines what your topology looks like, whether it has a persistent volume, what the replication requirements are, and so on. And so it becomes very easy to combine together an image, a bar file, and a Helm chart as a package and say deploy that. And Kubernetes can just take that and push it out into the environment as needed. And of course, we'll make that a lot easier for you to do if you're doing it within environments like IBM Cloud Private, where we're going to provide the cloud packs that make this sort of technique of combining these things together even simpler still. The specific question around whether you need a local MQ server, we've written a post on that. Just put the link up at the bottom of the slide there. And that should help you to work out whether that local MQ server is really needed. You may find there are circumstances where you thought you need it that you actually don't. So do take a look at that article just to see, because we are aiming to simplify as many of the scenarios and topologies as possible. Right, so that's taken us on a deep dive through that particular angle, the sort of application integration angle of fine-grained deployment. Lots of other topics we could cover on AIA. If Jason's kind enough to invite me back, I'm certainly happy to cover off other things as well. A selection of various links here. The webinar series, the podcast, which is the second link down, actually is the 1 to 5. Eventually, the 6th one will go in there as well. So we've taken the recordings Jason's helped us make here and put them up onto YouTube there. Keep an eye on the blogs at the bottom for various posts on this topic as well. Jason, I've not been able to watch the chat as we've been going through. Has anything come up there in terms of questions that you'd like me to address?
So what I've seen thus far, Kim, are just folks looking for copies of today's session. So folks, if you do have any questions that you'd like to pose to Kim before we wrap up today, you could do that through the chat, or you could also unmute yourself and put them directly to him. One thing I would ask, and I'm just about to take presenter control back, Kim, just so I can open up the poll. If folks wouldn't mind just taking a quick second and letting us know, what you thought of the session, and we could take that feedback and try and incorporate it into some future sessions. So I am going to open that in just a second. And one other reminder too for folks that do participate in the session regularly, what we will be focusing on next week is a new offering from one of our business partners, Ping Identity. They have actually developed a complementary API security solution called Ping Intelligence for APIs, and it integrates really well with both our API Connect and Data Power Gateway solutions to provide IBM customers some advanced cyber protection for their API infrastructure. So they're going to be joining us next week and reviewing how it's complementing our offerings and the added value you can get from really leveraging the two solutions in concert. So just wanted to give you a little bit of visibility into what we got coming next week. But again, if you do have questions now, the floor is yours. Well, if there are no questions at the moment, as always, you can reach out to either myself or Kim once we wrap up for the day, and we can always get you the answers that you need. But did one just pop through? So it looks like this is just another request for today's presentation. So like I said, I'll share that with all of you after we wrap up. Okay, well, if there are no questions, Kim, thank you very much for leading another one of these sessions. I know the series that you delivered in Q4 got tremendous feedback, so I'm expecting we'll see similar results today. Other folks, I hope you found this to be a valuable use of your time, got some really good information out of it, and hopefully you'll be able to rejoin us again in the coming weeks.
Cheers. Thanks, Jason.
Take care, everyone.
Thanks, everybody, for joining. Cheers.